if there's a DC component present in the signal, then the whole signal, all of it is depicted on the screen essentially. There's a way to, if I knew that there was a DC offset present here, and I'm not interested in the DC offset, but I am interested in whatever artifacts are occurring in this waveform, you can actually AC couple the input, and essentially this throws a capacitor in series with the input and will remove the DC component. So I'm going to demonstrate that by going, I'm at coupling, I'm just going to simply select AC. And I'm going to probably make a liar out of me. Dale, what am I doing wrong here? Let's see.
Oh, it's a coupling, not the display.
Do you have your
Oh, you're on trigger.
Oh, okay, I'm in the wrong menu. Okay, sorry about that. Okay, let me go. Thanks, Ben. All right, so vertical. Okay. So basically, I went from DC coupling to AC coupling, and nothing changed on the input. That DC component is still there, but it's because there's a capacitor added in series with the input. That DC component is removed, and only the AC portion of the waveform is displayed. I can bounce back and forth now. I have to fiddle with the trigger to make it look nice, but there's sort of that concept. And if for some reason I'm having a brain spasm and I'm sort of trying to figure out what's going on, and I want to make sure that 0 volts is still 0 volts, you can also couple to ground. And even if you have a signal coming in, your screen, and all the scopes will do this, analog or digital, they'll all give you a nice smooth ground referenced tray so that you can kind of do a quick sanity check and figure out what's happening, and then you can toggle back to coupling however you want.
Where was your signal on ground? Was it way up?
It's right now I have a DC offset of 500 millivolts.
Oh, so the ground coupling, you're actually just looking at a ground signal?
Oh, now my assumption, and if someone correct me if you know how this, I'm assuming that when you go to ground coupled, it removes the input from the amplifier chain, and it's because
it should be shorting the input out.
Yeah, it's not. You said it is shorting the input out or not? I've assumed that it's not, but
I think in the amplifier it's shorting it out.
It doesn't short out your probe,
okay.
Not the probe.
All right, but
the input.
And I've never fully understood how that part of it works. I've always just assumed that it sort of disconnects your input and shorts the internal amplifier input to ground.
Yes.
So
I don't know if that's exactly accurate or not.
So Clint, I was just wondering, like, the purpose of using the AC input coupling, like, would it be to look at ripples in your power line?
Yeah, I mean, if you had like 50 volts of DC and you had a 2 millivolt signal riding on top of it, there'd be no way you'd have to set it on a 50 volt scale to even see the thing, and then 2 millivolts would be invisible.
So it's essentially just to recenter the signal in the middle.
So you get rid of that 50 volts.
It removes the DC fixed component. Imagine you were looking at the output of an operational amplifier circuit that was some higher, it had a really complicated waveform, a lot of really fast things going on, sort of like Dale's design in the Polymax robot, which I sort of I had copied and with his help. And there's some DC levels in there. You've got to be kind of watching what's going on with your input coupling, or you won't. It really doesn't necessarily have anything to do with trying to test the power line. It's more of the electrical engineering aspect of it, of trying to remove the DC component of the signal so that you can more clearly see the part that is moving. Basically, you're removing the part of the signal that's not moving, so you can look at what the part that is moving, and by removing that DC component, you center it. You will always have the tray centered about the 0 volt. On AC coupling, I don't think it's possible to have you can't, unless you had some pretty exotic circuit, to have a signal rising up. I guess you could, but that could be pretty exotic AC sort of. Is that even possible?
Well, it is possible to have something you can't really look at. Like, suppose you had a 50 volt peak-to-peak square wave. On top of the square wave, you had like a half a volt signal you were interested in, on both the top and the bottom half. Well, it obviously wouldn't fit on the screen. And you might have to, if you took the DC out, you still have 50 volts of AC square wave. It's a little waveform on top, and you have to use your vertical centering. So maybe get it down, and maybe it would exceed the you overload your amplifiers. There'll be some issues there, but
Okay, so I know that's got to be an exotic circuit and something kind of beyond. So, okay, I said I was going to talk about probes real quick, and then I'm going to be quiet everybody just kind of talk about their own oscilloscopes or ask questions to the huge number of experts that are in the room here. Anybody ever like to watch Richard Feynman's lectures on physics? I think they're fascinating, and he's a very well-known physicist back in the, he's still alive, isn't he? Okay, you see in the bookstores these lectures on physics. One of the things he talks about that fascinates me, when they're getting down into sort of the quantum physics level of things that are happening, they're talking about things that are events that are occurring where changes are happening, but the physics and the mechanics of sort of what's happening in these events is so delicate and so easy to disturb that even the act of looking at it causes a change to what you're looking at. So if the mere act of shining a light on something to make it observable causes the event or whatever to not be viewable, then you disturb the event. Well, in the case of using an oscilloscope or any other piece of test equipment, that's something that we always have to sort of keep top of mind as well. Whether it be a multimeter, oscilloscope, or whatever, anything you attach to a circuit will slightly in some way or another change the behavior of the circuit. So there are a number of different types of oscilloscope probes made for different oscilloscopes, but your typical oscilloscope probe is going to have 10 megohms input impedance. There is a series resistor, I believe, inside the probe, and there's a small trimmer capacitor in here. I mean, everything in life, just in the electrical world, has inductive. It has capacitive reactance and inductive reactance, and you can even, leads going into an integrated circuit. You can't ever get away from all that. So you try to minimize that as much as possible. Your typical oscilloscope probe, 10 meg, I think, is the standard, isn't it? So, and this particular oscilloscope probe has an 8 picofarads known capacitance probe. So if you're putting on a very, very delicate circuit, you know that you're going to be introducing some potential for error just by the fact that you're doing that. Well, there are other types of oscilloscope probes made. You always want to make sure that you have a probe that's suitable for your oscilloscope, that has an appropriate bandwidth. And as somewhere I was reading this particular oscilloscope probe is rated to 500 megahertz, and I know as a match for this particular oscilloscope, typically I guess you want to have the bandwidth of the oscilloscope be at least 5 times whatever the highest signal speed you're going to be looking at is. Is that what y'all have heard, or is that, doesn't necessarily have to be that to get an accurate thing, but and then if somebody else could explain to me, I also have a set of FET probes for this, which I believe are really more for high frequency. The other day, Barry Ward, another former Robot Club guy, and I were talking, and I always thought FET probes were to allow a higher impedance input into the probe. And Barry said, no, that's not true. Look at those probes, and sure enough, they have like a 1 megohm input impedance, but they're designed for very high frequency and really fast switching time. So there are a variety of different types of probes that are available.
There's also differential probes if you're dealing with something that may not be common mode, but more normal mode operation, where like if you're trying to sense the drive circuitry on a motor, and say the motor is an H-bridge circuit, so both ends of the motor are floating. How do you observe that across the motor? You have to have a probe that has 2 differential signal outputs, or inputs, I should say.
Okay.
And I use that commonly whenever I do a motor couplings.
And is that two input? Does that mean 2 inputs on the scope, or just
no, one input?
Okay.
You can cheat with the scope that can do a plus and minus differential.
Okay.
But it's safer to buy a probe that's designed to be differential and have a battery in it so that it has its own power supply.
Okay.
And they're usually got good isolation of up to like 600 volts, so that you don't blow up the ground.
Okay.
So they're naturally safe to the earth ground of your scope.
Okay.
And so whenever I'm dealing with high power motors and I'm trying to look at the drive circuitry, I'll use a differential.
Okay. Very interesting. Okay, I've never played with one of those.
And it would just take one B and C into your scope, but it's 2 separate clip probes going to your target.
Okay. Right, that makes sense.
Basically, that's an isolated probe.
Yes, it is. Well, it's not fully isolated, but it has isolation up to 600 volts in a sense. Enough that the typical circuit can tie into Windows
Yeah, I
or
guess that would,
Someone,
I guess that would make
Okay, well,
sense. I've never seen those.
At this point, I'll just
came
open it
with
up
Yeah, that
for
would take, because you gotta
open
find every duct
discussion,
next
if
to your
people
ground.
fiddle with their own
over
scope
there.
and turn the lights on, and I don't know, a lot of people took the time to
You got your
their own
ground
scope.
right
If
there.
they've got questions, answers, we'll just kind of go into a sort of
someone
overlap
told me, I don't know what,
Okay,
I don't know if it's like
so
And feel free to,
a gig or
scopes around,
when
go
you'd
on
want to
buttons,
use
rub
these,
the push
but
buttons, fiddle, play with the
there's got these
signals, whatever you
pros
want to do.
long ago.
So I don't have a scope, and I'm thinking about buying one, but I don't want like a
Yeah,
big,
these
you
right
gotta,
here?
for
Oh,
how
the
often I
adapters.
would you actually have time to use it right next to you. What about some of these
Okay.
little ones, you know, or like the pocket ones, based off an old cross or anything? Are they gonna be okay for doing
Yeah.
not really, not without
Yeah.
the ability.
Ground plane, circuit doesn't have that kind of
The only thing I
have
can
a
do is
ground
just
plane.
put in the IC chips, see if there's
So what does this address? Does it address the capacity?
reseat them.
Yeah, what you need to do is,
I don't know.
probe on to
So, the deal on those,
He gave me the,
DSO,
booklet.
Dale has one.
Actually, it looks like it's a design and then people will take it and build it and sell it as a.
I can tell you that the C Studio version
got something looks like that.
Yes.
the screen on it is great.
So I've always wondered, I know that calibrating bar is to calibrate it somehow, but what exactly does that mean? That, is it just putting out a 1 kilohertz oscilloscope? And so you can adjust your, these ones, pulse television?
Yeah.
So, I mean, I've only just displayed, you know,
Okay.
square waves,
Delay
shots
shapes,
on it, since I played
Straightforward.
golf.
Okay.
But, yeah, and of course,
I wasn't sure if, one of them I used to have, I guess a cow. You have a frequency, and so they always usually like 1 kilohertz? Okay. Yeah, I understand.
And, of course, these don't take up much space, they're very portable, so really it's, not a lot of bandwidth.
Oh, okay.
The screens on the DSO cameras, I was shocked at how clear the screen is, and how much information it saves.
I was thinking, the,
put together.
Oh, wow.
So that works
Oh,
fine.
okay, did you get the one that's the spare circuit board? It has the LCD and do you remember?
I just reseated some chips.
I've been tempted about one of those.
I don't think it will.
Yeah.
We gave away
I think what's cool, it made me focus on the whack.
We can synthesize.
Last time I had it working,
Yeah, this is the exact one I went with.
That's a lot nicer.
The square. I was amazed.
That's the thing. That was the focus.
The port channel is $300.
Well, I paid $65.
It could
you
be
got
something
a,
else. I mean, let's say,
Yeah.
But it worked fine.
PWM signal or something on that? You wanna-
Well, here's what I have in mind. I'm looking at these 70s line following sensors on here, and what I do is really best. When I turn this on, this samples the array, and I just really try to do like cut down the time that I spend eliminating each so I wanted to know, like, I wanted to trigger when I like raise the power line high, trigger, and then see how long it takes for the signal line to go active, and then so I can minimize the amount of time I wait before I sample.
Do you have that code running? I mean,
Yeah, it's running. If I flip it on, it should be
It
running.
comes with two little alligator trays.
You want to put these?
And it has a function, not a function generator. It has a
Yeah, I've got 2 of them.